Now I'll walk through each section of my R code and explain what it does. First, we have to load the required libraries and load the dataset. The required library to do this assignment is library dplyr. We go ahead and run that. And then we have to load our data using read CSV. We go ahead and run that, and then I use this code, column names, which helps me to display the column names to confirm a variable availability and helps me select the correct predictors for each model. We run that too, and then to answer question 1, we have to create a new data frame considering variables from 2015. The variables from 2015 include American Indian and Alaskan Native, obesity, limited access to healthy food, diabetes, poor or fair health, frequent physical distress, median household income, Hispanic, children in poverty, adult smoking, and inactivity. We go ahead and run this code, and then we see that our 2015 data has 11 variables. And then we go ahead and create a model for the year 2015. Based on the model in 2015, the R square is 0.76, which means that 76% of the variation in diabetes rate in 2015 is explained by the predictors. This is a very strong model, and it shows that significant predictors in 2015 are obesity, limited access to healthy food, poor or fair health, physical distress, household income, and Hispanic population, children in poverty, and inactivity. And this is the answer for question 1. Question 2, we have to do the same thing that we did for the year 2015, but instead we are using the data from 2016. We use the same code, and we run it. This gives us the data for 2016, gives us only 5 variables. The variables from 2016 are American Indian or Alaskan Native, obesity, diabetes, poor or fair health, and inactivity. And then based on these variables, we create the regression model for the year 2016. Based on the results for the year 2016, the R square value is 0.39, which means that 39% of the variation in diabetes 2016 is explained by 2016 predictors. This result is noticeably weaker than the year 2015. Which means that fewer strong predictors were available in the year 2016. The significant predictors in 2016 include obesity, poor or fair health, and inactivity. And then to answer question 4, we have to combine the data from 2015 and 2016. So we combine the data and we run this section of the code, and then we are creating the model 3 regression, which is from combined data from 2015 and 2016. Based on the result on model 3, the R square value is 5.5749, meaning 57% of the variation in diabetes 2016 is explained when both years' predictors are included. This is stronger than the year 2016. The variables that impact diabetes the over 2 years are obesity, diabetes, inactivity in 2015, and then obesity and inactivity in 2016. This shows that behavioral variables like obesity and physical inactivity have persistent long-term effects on diabetes incidence. And then this also shows that when both years enter the model, 2015 and 2016, 2016 variables absorb part of the variance explained by 2015 variables. This will create an overlap, meaning some predictors will no longer appear statistically significant because their effects are shared with other variables, and that's why some variables drop out when both years are included. This is common in hierarchical models because later year measurements often capture similar information with a smaller error. And this concludes the answer to assignment question Module 5 question 2. And to summarize, hierarchical modeling allows us to understand how diabetes predictors behave within a year and across years. The 2025 model performed the strongest, and 2016 model was the weakest. And when we combined both years together, we had a balanced improvement. This analysis highlights the importance of multi-layer health data and understanding chronic disease patterns, and specifically diabetes that we looked at. And thank you for listening. I hope you enjoyed this video and the breakdown of hierarchical modeling for diabetes incidence. Please let me know if you have any questions. Thank you.